And the base conversion is easy. This time there's no division, nothing involved. I just have to regroup the bits in chunks of 4 and then look up the table. Now it's just a 16-item lookup table. If you do this enough times, you can memorize the table in no time. What about the other way? I give you the hexadecimal number. How do I convert it back into binary? The other way around. Okay? That's why base 16 is so useful, because if I need to represent a 32-bit number, I just need 8 digits. It's actually more compact, slightly more compact than base 10. And yet it retains all the nice properties of base 2. Are we doing okay so far? Kind of? Okay. Yep.
So that's how the colors, like the colors and websites and stuff, that's how it's based on.
Yes. That's why I think it's thinkgeek.com. They send me an email, to remind me to buy, Valentine's gift for my wife and stuff. So it says, rose. Most people say roses are red and blah blah blah. It says roses are pound FF0000. And I found it to be very cute. Unfortunately, my wife is not, kind of as geeky as I am. So, and I think she may not appreciate it as much as I do. But it's really funny because they just use the HTML method of encoding color in RGB. Yep. All right. So, well, that was a digression, but it does come back and explain why these programs, why this particular program will terminate, even though you think that it will not terminate, it does terminate. Okay. Any other questions? I need to resave this file, but under a different name. So I think I would rename this one as infinite repeat. Yep, go ahead.
So in summary, the only reason why a supposedly infinite loop will end in certain programming languages is because of the binary limit.
It's not a binary limit. It has to do with a fixed number of digits. Okay. In other words, if I use base 10 and I say, but you can only represent numbers using 3 digits, then you still have a range of, you only have a certain range of numbers or values that you can represent. So it's the same problem, whether it's base 10 or base 2, it doesn't matter.
So in other words, it's only the program would only be limited by how many digits?
The number of bits per integer, correct.
Right.
And the most popular one would be 32, but we are transitioning to using 64-bit as the quote-unquote norm. The standard number keeps changing because it used to be 16, and then we moved to 32, and then from 32 we're moving on to 64.
Then eventually we're 28.
Yep.
Depending on how many people are left on the planet.
Yep, go ahead.
So when programs are compiled into binary, how do the if-then statements convert into binary?
Okay, there are different answers to your question depending on what you're really asking. The instructions that you write in C and C++, they only make sense to us as programmers, but it doesn't make any sense to the processor. The processor cannot look at if as if and understand, oh, this is a conditional statement. So the computer only understands opcode, operation code, and those are weird, binary bit patterns. Okay, to add 2 numbers, the instruction maybe 0011001011001100. It's a 32-bit long bit pattern to specify just the instruction to perform an add operation. Another one for comparison and so on and so forth. So by the time it translates to the level where the processor understands, it's no longer in the high-level construct that we see in the C program. It'll be translated into assembly code or machine code. And programming in machine code is entirely different compared to programming in high-level programming languages like pseudocode that we use in this class or C and C++ in the next class. cisp300 is the class that will talk about assembly language programming. And in that class, you will start to see C program or C++ program on one side, and also assembly programming on the other side. Assembly language is really one step on top of opcode, the binary opcode thing. So that's pretty much as low level as you can get when it comes to programming or processing. Did I answer your question?
Yes.
Okay, thank you. Any other question? No other questions? All right. So we have encountered the two types of loops, and that's pretty much, let me go back to the browser. Okay, that's pretty much what that particular slide is, that talks about loops. The next topic has to do with nested statements, which is one of the questions that one of you asked earlier. Can we put an entire loop inside a conditional statement? The answer is yes. The question that you asked to visualize why we can nest things like putting entire statements inside another statement, it's kind of like putting a folder inside a folder. Okay, it really is the same kind of concept of nesting. Why would you want to put a folder inside a folder?
So, like,
Category.
save things in different areas, so you can go into that and kind of deal with that more.
Okay.
Organization side of things.
It's for organization. Very good. Go ahead. Okay. But the organization has to match the things that you're trying to structure, that you're trying to represent, right? And it's the same thing in programming. So in programming, you can use nested statements where you can have a conditional statement inside a loop, but within that conditional statement, one branch may be an entire loop, the other branch can be just a simple assignment statement. So all of that stuff can nest. I want to, we still got about 3 minutes. So what I want to do is to show you this slide here. This one is already a nested statement. I just never called it nested. How many statements can you count here? Now, the way you count this one is a little bit tricky. Let me see if I can do something like this. Copy URL. So this is what I'll do. Right here. That's not very helpful. All right. Okay, so I'm counting one statement. Line 1 is one statement. Line 2 to 4 is one single statement. It is a while loop. It's a pre-checking loop. But line 3 is a statement too. So line 3 as an assignment statement is called nested within a pre-checking loop, which is from line 2 to line 4. Okay. So from the outermost level, if I look at this from the perspective of folders, I have one single folder, which is the root folder, or your C:\/ drive, and it has two things. It has one file, which is line 1, because an assignment statement in this class cannot nest and contain other things. So this is a file, it is not a folder. And then it has a folder. The folder is the while loop. And within that folder, we have another file. So if I were to translate this using the terminology of files and folders, then the outermost layer has one file, one folder. Within that subfolder, we have one additional file. And that's how we can look at this from the nesting or the structured perspective. Now, it is a very important topic. The whole concept of being able to nest or be able to contain one statement within another statement is very important. Because otherwise, what are your current tools that you can use for programming? You have assignment statements, you have conditional statements, you have pre-checking loops, you have post-checking loops. Those are the only 4. How can you create complicated and useful algorithms using these 4 when you cannot nest? It's not possible. Okay, so we got about 20 seconds left. So what you need to do is to at least look at this code here and try to trace it and figure out what it does. There are specific places of this code that is a little bit tricky and other places that are really straightforward. So go ahead and do this, as a brain teaser, if you will, as a homework assignment that is not going to be graded, if you will, because the answer is actually right next to it. Okay. But I want you to approach this and try to trace it a few times before you kind of look through the code and find out what it is you're going to do. And then we'll talk about this on Thursday.
You know what I realized when you